Okay, so Danny's homesick.
No.
So, I know. Wow.
Danny.
Okay, so let's chit chat.
Or
We have
maybe
3 weeks left.
2 weeks.
Actually, 2 5 days, and then that last week is jacked up because of the stupid final schedule. But because of May South, thank you very much. No. So here's how this is gonna play out. So this isn't like you guys are responsible for
Are you sure about that?
it. It might be.
Let's blame them anyway.
Okay.
Yeah, it's
I
their
like
fault.
So your test over energy is going to be Wednesday of this week. Okay? So we're done with all the theoretical stuff. You got a simple lab today to figure out energy of a rolling tennis ball. Okay? Which, yes, Preston, you have to add the rotational energy to it. Okay? So then we'll review tomorrow. That test will be on Wednesday. Then we've got like thermodynamics, buoyancy, gas laws, fluids to do. Okay? That portion will all just get rolled into your written final, which will be on Tuesday, December 17th. And then you guys have a 2-day lab final, which will start on Wednesday, and you will finish up on, I don't know, either Thursday or Friday, whichever day I have you guys. Yes.
That sounds like a lot of things to cover in 2 weeks.
It's actually not.
Well, is gas law? Is that like I would have maybe learned in Chem 2?
Yeah, but this is the physics version of it. Units are different, how we represent it is different. They use liter atmospheres, we use Newton meters. So
Do we get
it's
to
the
use,
same equation, PV equals
Yeah.
RT, but
Okay.
the
do we
approach
use
to it.
tors?
Huh?
Do we use tors or
Oh, no, we use atmospheres, which are equivalent.
millimeters?
Actually,
or
atmospheres always gets converted into Newton meters, so it's 101,300 newtons per square meter, which is what we use for as a standard pressure, which is equivalent to 1 atmosphere. Okay, so let's chit chat about what is going to be on the test. I promise you, there's going to be some version of like 2 and 3 on the test, and also that question on number 5, because that's going to form the basis of the lab that we're going to do today. So let's talk about question number 4. Excuse me, question number 2.
Yes. More yes.
So this thing is swinging down. So you all have been on Thanksgiving vacation. I'm assuming you'll have offloaded any bit of knowledge you might have had about physics. So since it's already moving, what 2 types of energy does it have?
Kinetic and gravitational.
It has KT, naught, and some UG. Your UG is going to be mgh, and this is where you have to use that equation that H equals L times 1 minus cosine theta. What that gives you is the actual height above the equilibrium point, okay? And if you need that equation on the test, I will give that to you, okay? Now, when it hits the bottom, what's the only type of energy that it has?
Kinetic.
Kinetic, relative to that system, okay? So you can go, oh, that's mgh plus 1/2 mv naught squared equals 1/2 mv squared. Now, conveniently, you can multiply by 2, factor out the g's, you get, or factor out the m's, you get 2gh plus v naught squared equals v squared, otherwise known as that equation. So you just use that equation to find that velocity. So that answer to 2A should be just a titch above 4 meters per second.
Okay. Okay. Good. That's
Okay?
good.
3 significant digits. So help me, if you wrote 4 meters per second, I'm going to lose my mind. Okay?
I'm gonna have to transcribe this assignment. I just realized that I did 1 and 2 without writing the line thing, so all of the work is bad. I'm just gonna start transcribing this assignment, like now.
You know, what if you just not said that, and then?
Oh, I would have lost my mind.
Oh, he would have
Yeah.
noticed.
That would have been worse.
Okay, like just
Exponentially
dropping that on you.
That might have led to like blood and suffering. Okay,
Cool. I
so
made the good decision, guys. Good choice.
2B, because now it turns into a California problem, that should be around 3, because you've increased the mass, decreased the velocity. So on 2C, you want to figure out that energy value, that should be a little bit above 1 joule. Okay? Now, on 2D, you're trying to find that angle when it swings up here. So basically, what you got to do is say, okay, this thing has all kinetic energy at the bottom after it's collided and moved off. Then you can figure out what that height is, because at that point, it's all UG. So if you know how much kinetic energy you have down here after the collision, you know how much UG you're going to have up there, you can figure out the height, you know the length, algebraically solve for theta, and you should get an answer in the mid-40s.
Yes, I somehow did that right. I was,
Okay? So that's kind of a complex problem. Now, on number 3, your answer to 3B should be around 10. Your answer to 3C should be around 40.
Wait, which one should be around 40?
3C.
How does 37.0
Oh, yeah.
sound?
Is that around 40?
I mean, it's kind of close, but
Hey,
That's
Gap
what I
Sean. It's okay.
That's what I got going.
okay.
I got 37.1. I'm closer. That my answer's better.
It's valid. Okay. Now, on number 4, I promise you, there's going to be a satellite problem on the test.
Like,
Are we gonna have to do orbital motion in this satellite
No.
problem?
I promise you, I'm going
I
to
put that on just to get you ready for the written final. Okay?
I was doing really good until you said find the orbital period. My brain went, nope.
That was the easier part for me. 'Cause you just
Honestly, yeah, that was not that
Wait,
bad.
what'd you guys
Because
do
that one I
on-
was like actually sure of my answer. The rest of it, I'm not even sure.
Okay.
No idea.
Anyway, back to our story.
Right.
So if your answer to 4A is wrong, everything is going to be wrong. Okay? So that should be 0.011 and some change.
Just too
Okay.
much change.
I would say 2 is change.
I like 2 as change. Now, when you get to when you get to 4B and you want to figure out that force, remember that torque equals 2 things. It equals force times radius, it equals I alpha. But it asks for the force from each engine, so your answer to 4B should be around 20.
Okay. I really tried to do that wrong because I almost forgot to divide it by the number of rockets. And
Never says that they're doing equal work.
after I divided by the rockets, I went back and tried to get rid of the 1/4 from earlier. So it was a whole thing. I got 80 twice and then fixed it. So we're good now.
There's
That was a long-winded story to say you got the right
Your
answer.
answer to
Cool story.
4C should probably be less than your age, maybe close to yours. Okay.
Is it-
I'm 16 now.
is it
Not to brag, but I am 16.
is it 5 times an OK GPA?
I'll give you that. Heavy on the okay.
For what?
Which one?
15
Uh,
for 4C.
on your answer to D should be something times 10 to the 5th. Your answer to E should be something times 10 to the 4th.
Okay.
And a
Okay.
very good GPA.
That is a very solid GPA.
Collins GPA.
Both your answers to G and J should be the same answer.
Yeah, I was not getting that. I don't know.
For which two?
G and J.
I got G,
And J. Wait.
but J.
Both
is-
should be something times 10 to the 11th.
They should be the exact
J.
same. Oh.
Would it be
oh.
maybe 2 point?
No.
Dang.
I got 3.97 times 10 to the 9th. That is not.
Oh, God, no.
I'm not even close.
How? So.
I didn't even.
What about
Yes,
H and
I didn't
that
even write down
attempting
an
got me
answer.
That means I
somewhere.
calculated H and I wrong as well.
I haven't written down an answer because I know it's so far off.
Okay, on G, you have to find the velocity.
I somehow did that wrong.
Okay.
So you know, you want to find that kinetic energy, which is 1/2
Oh.
mv squared.
Oh.
Okay.
That's what I did.
And to get the velocity,
That's what I got.
orbit is big G, mass of the Earth over R. So if you want to get clever,
Oh yeah, I remember that.
I got
since
G.
that gets squared,
Just get rid of that square root.
yeah.
So.
How do I screw this up then?
I don't know how.
If you find the velocity by itself, it better be something times 10 to the 3rd and start with a 7.
Okay, yeah. So that
That's what I got.
squared times the mass, right, would be your.
And 1/2.
Oh.
Wait, so how did you do J?
I was doing it right
So,
the first time, and then
My
I
J
don't know,
is
my brain and I
not
added
right.
Something completely different.
So. Okay. Let's
On
refresh.
J, you're going to find that rotational tree that's a point mass. You can have 1/2 I omega squared.
So would it maybe be 1.09?
So that's what I was doing.
Times 10 to the 11?
Yeah.
Would that be it? There we go.
Wait, so that means one of my numbers
Silly
in here
me.
is wrong.
What do you have for H, Will?
For H? 5.33 times 10 to the 3rd?
That's cool.
Yeah, that's what I got too. So G, that should be for G, the 1.09, the number times 10 to the 11.
Yeah. And then J should be similar.
Because they're the same number, or because they're.
Like the same times 10 to the 11th. I don't know if it's the same number or not. Because, I don't know, I'm doing one of my numbers in my
Should we
equation
like
is wrong.
1.08 times 10 to the 11?
1 point what?
1.08.
Yeah.
Yeah.
So.
So can I show you why they're the same?
Yeah. You have my permission.
Okay.
You have my permission.
God, you made South people cheeky.
Kids these days.
Okay. So if you look at 1/2 I omega squared, right? So since this is a point mass, how are you going to find I?
The MR squared.
What did you
Right?
Yeah.
Yeah.
True?
Mm-hmm.
do? True.
Now, velocity equals R omega. True?
True.
So omega equals,
Oh, I just.
V
Velocity times. Oh.
over R squared.
Oh, and your R squareds cancel.
What do you know?
Simple calculation
What a
error.
time to be alive.
That's why.
that's why you get the same answer.
Just a simple calculation error.
Just
I did the wrong
It's quite
operation.
simple, really.
Cohen's like, ooh.
I did
That's a
the
lot on a Monday morning after Thanksgiving break,
So that
man.
should be
This
the answer
is-
J.
It's
So that's why the answers to G and
J are the same.
Yeah, that's what I.
Because if you simplify, if you substitute rotational in for kinetic, and it only works in this situation because it's a point mass.
Yeah, and I guess it's like this kind of like rotation is really the only force acting on it. It's that gravity.
Yeah, so basically, instead of going like this in a linear, you're
It's
going like
that in a
this.
circle.
But it only works with the point mass. But
Orbiting-
that's why
orbiting
you
it.
get the same answer.
Okay.
What's the like symbol for angular momentum?
It really does.
L. And it's
Number 5, and I promise you there's going to be a question like number 5 on the test. That answer to 5A should be about half of 5. So, just so everybody's cool, because you're going to need this for the lab today. So when something rolls down a hill like this, okay? So this is what you're gonna do in the lab. You're gonna have set up like this, you're gonna have a tennis ball, it's gonna roll down the ramp, okay?
No.
So as it rolls down the ramp, what two types of energy does it have?
Rotational and kinetic.
Yes, it's gonna have Kr and Kt. But if you just hold it up and then just drop it off the back of the ramp, you only have
KT and UG.
Kt,
Oh,
okay?
we're not counting UG?
Well, your UG is gonna change, I'm saying when it hits the bottom,
Oh,
okay? But in both situations, you have the same amount of UG, okay? The only difference is in this one, you're gonna split it. In this one, it's all KT. So this is when, Preston, listen to me, this is when you gotta go in and go, oh, that's 1/2 mv squared, that's 1/2 I omega squared, and that's when you gotta do your I value and get all your data for that, what moment of inertia are you gonna use, and the biggest thing, just like we did, is that V equals R omega. So omega equals V over R, and you can substitute that into that. So keep that in mind when you use your lab. Okay,
so wait, just to clarify, at the bottom of the ramp, the kinetic energy plus rotational energy has to equal the UG at the beginning of the beginning.
absolutely. That's the
Okay.
only way it works. Your energy has to be conserved. If it doesn't, I guess my question, what else could it equal?
It's lost his.
that was my brain doing a walk and then making sure I arrived at the right place.
Did
you
you
do
end
it
up in the right
quieter?
place?
I think so, yeah.
Okay, very good.
That's what I was asking you.
Okay. 3 more Sprite days.
Yeah, 3 more Sprite
Christmas.
days. And then Christmas.
Ooh.
I love Christmas.
Do you have like a Sprite cranberry shirt?
I don't. I don't, but if you bought one, I'd wear it.
But would that usurp the normal Sprite Day Tuesday? Or
Oh, I didn't think about that.
I'm just telling you, you need to think these things through.
Here's what would have to happen. What we need to do is we need to make a pin on cranberry sign that I pin onto the original Sprite shirt
Just for the Christmas
for
season.
the Christmas season.
My theory is that you don't wash it.
Okay, all right. Are we good? Going once?
A gap for
Going twice?
Wait, he wants the gap
I on forward.
For what?
for I.
What?
Not for I like for me.
Something
For
times 10
I.
to the 14th.
For 4i,
Yes. What do you have, Gap Shy?
1.93 times 10 to the 5th.
Oh my God!
Jeez.
Whoa, that's off by just a little bit.
I got something.
Just a
fun.
I'm really
snitch.
sorry.
Just a few
God, I gotta go
magnitudes.
back.
Bro, I'm really
Johnny
sorry.
Depp.
I didn't.
Much stupid.
You're just gonna L equals I omega.
What'd you get for the
Yeah,
omega?
Omega for I.
let's just say that
Yeah, like what'd you
I
get
was
as
very
the
stupid when I was
Taylor?
doing this.
Honestly, I just put in like my numbers. And
All I say is a good
Oh.
thing. I already had that about
I didn't like solve for that. I just put in my numbers.
I need to
Oh,
go
you-
back. Like
I just
let
like
me
put it
change
all
some of
into the
these
equation and
Yeah.
then
And you were doing
Solve
your
it.
What'd you get for the equation for that? 'Cause,
Science, no. Push him into like.
well, I got 1.01
You guys need
times
get
10
a
to the
restraining order against this student.
Yeah.
yeah, I know. Did you,
Don't let him.
I know,
even
but
near
like,
your bookshop.
how did you get the velocity, the angular velocity?
Okay, stop yonder camera.
Beep.